Okay, so let's get started on the second session. Our speaker, Riley, will speak again and to give us an overview of decentralized finance.
Thanks again for being here. I'm going to present the second portion of the lectures now on decentralized finance. So jumping right into it, decentralized finance really allows for a variety of users to participate in actually owning systems that allow for peer-to-peer finance to occur. So whether that's being able to do something simple, such as just exchange with one another, or something really complex. These systems allow for both the risk and the reward to be distributed to potentially thousands or hundreds of thousands of people, and that really creates more equity within these systems for finance. So not only that, but by allowing for finance to be decentralized in this way, it can be much more secure and transparent than in the context of having sort of centralized finance. So, like I said before, it can be really simple. When we talk about decentralized finance, it could just be an order book or an automated market maker, AMM. And both of these are forms of decentralized exchanges. These allow for people to trade one token for another token, and you can do so just with other users. There's no sort of third-party intermediary that is allowing for that exchange to happen. It's just the blockchain and code. We can also have really complex systems built out, though, with decentralized finance. One of my favorite examples is the ability to have self-repaying loans and having that in a way that's transparent and auditable, as well as secured by smart contracts. I think that that really excites me. There's a couple of examples of that on Ethereum, and I'm hoping to one day bring that to Cardano. But yeah, I mean, decentralized finance can get really complicated with like all of the different primitives that are available. I'll walk through quite a bit of it today. In the context of decentralized exchanges, like I said, there's order books, which are pretty simple, and a lot of people are familiar with these, but they're not used nearly as widely as automated market makers, which actually allow for people to pool up a bunch of capital for token A and B into these liquidity pools. And when a user does that, they're given a token that represents their percentage share of that liquidity pool. And so, like I had said in the previous talk, the ability to mint these digital assets in a way that's secured by a smart contract allows for us to actually have percentage share in these equitable systems, all secured just by code. These tokens that are used to represent liquidity, not only are users able to sort of earn some sort of yield from just the fees that are occurring on the decentralized exchange, but generally, in order to incentivize people to provide liquidity, exchanges will reward users with a governance token for staking those liquidity tokens. And so if you take those tokens and stake them into another contract, you'll be rewarded some governance token. And as I had said in the last talk, decentralized autonomous organizations are sort of these groups that form on blockchains, and a lot of the times in the limit they are used to manage peer-to-peer decentralized systems. These exchanges or lending protocols or whatever it may be can actually be directly governed, and these tokens for governance are rewarded for providing liquidity to these systems. In the context of decentralized exchanges, that actually helps quite a bit with impermanent loss, which is sort of this concept that if token A and token B sort of go and deviate prices from where you provided liquidity at, you're going to be better off having just held both of those tokens individually as opposed to providing liquidity. So there's a lot of risk in providing liquidity to decentralized exchanges, and that's where those rewards come in. The next thing I wanted to talk about, which is highly relevant to being able to provide liquidity and actually earn because of a lack of impermanent loss, but also just for day-to-day life of most people, is stablecoins. Stablecoins take many forms. The sort of most well-known stablecoins are Tether and USDC, so USDT and USDC. And these are actually backed directly by fiat capital. And so if you go to Circle, which is the company that sort of runs USDC, they manage the capital that's backing that token, and it's all very centralized. Additionally, there's stable tokens out there that are represented actually, again, using smart contracts. They're minted and burned, and the ability to mint these tokens is reserved to over-collateralized debt positions. And so DAI is a great example of this, DAI, on the Ethereum ecosystem. It's been working for a multitude of years without any issues in its stability, and it's because it has a very high level of capital efficiency. If somebody's over-collateralized debt position falls to a certain collateral ratio, any user can come and liquidate that other user. So there's always sort of a motive to keep the system working. And I think that this type of system makes a lot of sense for decentralized finance. It's not sort of backed by some centralized entity, but it's also not like what we're going to talk about here in a second. I'm actually going to skip over the commodity-backed stablecoins, but you can have commodity-backed stablecoins, and it's similar to the first camp where there's a centralized entity backing a token by fiat, but instead it's just commodity-backed. Instead, I'm going to skip right over to algorithmic stablecoins, and unlike over-collateralized stablecoins, which DAI is a great example of, algorithmic stablecoins is a much looser sort of concept, and it's used to describe a variety of stablecoins that generally don't work. UST and USDD are good examples of algorithmic stablecoins. In the context of UST especially, there's been a lot of money lost recently due to sort of the way that this system was designed. Users could burn UST to receive newly minted Luna, and so the Luna supply inflated rapidly as the value of it went down. Even more of it was needed to sort of be minted in order to back any given UST, and the value of both plummeted. UST, I think, ended up going down below 30 cents, and I'm not sure where it is today. I would highly recommend people stay away from these types of systems. Yeah. So when it comes to synthetic assets, we can represent gold on the blockchain or anything really that can be given to the blockchain as a secure data feed. And so there's one sort of group or blockchain that is used pretty widely for data feeds called Chainlink. And I'm sure a lot of you have probably heard of Chainlink, but it's blockchain agnostic, but it's also in and of itself a decentralized system, and it allows for data to be sort of aggregated from many points to feed onto a blockchain, and that can be really useful for both creating stablecoins like DAI, but also for creating synthetic assets, which follow a very similar model using over-collateralized debt positions. And so by having a high capital efficiency within these systems and by maintaining over-collateralization, both synthetics and stable coins can work really well. And like I said before, there's systems that have been using this type of model for years without really any issue. The primary risk around systems like this are going to be smart contract risk. Like I said before, smart contracts are very sort of prone to error, and people that are writing them need to be very careful as such. The next thing I want to kind of touch on is decentralized lending. And the basics of decentralized lending are really quite basic. You have one user who's going to go and request a loan. They're going to put up some amount of collateral, which may be more or less than what they're requesting for their loan. They could request that their loan be taken out in a different asset than what their collateral is provided in. Another user is matched to that loan, and the loan sort of goes through. There's all of these stipulations that are provided, and that's it. I mean, it's just a loan that's secured by a smart contract, and if the user defaults on their loan, then the collateral is released to the lender. You don't need escrow, obviously. But decentralized lending isn't really all that useful if that's all you can do with it. If you always have to match users with other users, it's really not something that can be used in a way where it's a primitive for all of these other systems to be built on top of. And so there's been a number of what are called money market makers that have come to the market and sort of allow for, similar to in the context of DEXs, where you're providing liquidity for people to exchange against. In these systems, you can provide liquidity for individuals to lend against. And in order to lend, you have to have collateral that's backing that loan. So the idea is that any loan taken out in these systems is generally over-collateralized, and people are going to use that sort of loan that they took to try and earn more than what they are paying in that borrowing rate. So in a way, the big benefit here is, like I said, anybody can come and easily provide liquidity to this lending system without having to worry about dealing with a specific borrower, and they're able to additionally borrow without having to deal with a specific lender, all pooling their capital in a way where they receive these tokens similar to those liquidity provider tokens in a DEX to represent their share, and those tokens are yield bearing because the utilization of the market is going to actually feed back into that pool. That pool is going to be always growing, and then people are being rewarded based on that. There's sort of a concept that has arisen called yield aggregation and another one called yield optimization. And the idea is just basically people wanting to utilize their capital in the most efficient way, and then wanting to optimize that use, or not optimize, but automate that use. And so in the diagram that you see to the right, this is actually from Yearn, and the idea in all of these systems is the same. Assets are going to be used to go earn yield. That yield can be collected and used to go and earn more yield, and that's the idea of yield aggregation. In the context of optimization, we're actually looking to be moving assets dynamically from one place to another. Some examples of where assets might be used to earn yield, like I said before, is if you're lending out assets, if you are providing 2 stablecoins to a DEX with appropriate liquidity, people can swap against those. You're always earning fees, and you don't have the risks of impermanent loss as long as you're using stablecoins that actually are stable. And then it's, I mean, there's a lot of reward-bearing mechanisms for providing liquidity, and so sort of by using all of these systems in tandem, smart contracts can be written in order to optimize and aggregate yield for a variety of users. And this is done, like I said, on Ethereum. The best known sort of system for doing this is called Yearn, Y-Earn, and I would recommend looking into that if people are interested in this. Like I said really early into this talk, one of my favorite concepts within decentralized finance is the concept of a self-repaying loan. And so we've talked about synthetics, we've talked about lending and yield aggregation and optimization. If you take out a self-repaying loan from Alchemix, for example, the way that this works is you're actually able to go and deposit a bunch of assets into Alchemix. Those assets are automatically going to be used for yield aggregation, and at that point, you're able to sort of borrow against your future yield. So you can go and take out, say, between 40 and 60% of what that capital was worth, and you're not taking it out in the same digital asset that you just deposited. You're taking it out in an asset that represents that, another synthetic, and that synthetic isn't backed directly by some sort of vault where it can just be sort of redeemed, but the way that it is backed is by that future yield. So any of those synthetic assets that are taken out in the form of this self-repaying loan can be either sold to another user, or they can be deposited into a contract that's part of this system, which automatically is going to be feeding out some of the yield from the entire system into that to sort of exchange the underlying asset for the synthetic asset repeatedly and allow for users to sort of get the value of that synthetic asset back. And so this is something that I know personally a lot of people that have used these systems in other ecosystems to pay for homes, boats, and other things without having to sell their crypto, because the assets are issued in the same sort of representation as what they're taken out in. Before the end of this talk, really wanted to get into the topics of identity. And this is something that is pretty novel. A lot of blockchains don't right now have any system for self-sovereign identity. I think there's a couple of different competing solutions that are trying to come to market that are blockchain agnostic. The diagrams I have on my presentation today are actually from Atala Prism and some of the research they've done into self-sovereign identity. In a centralized identity model, you have organizations that you're interacting with, and you go to this organization and they issue you an identity, whether it be government or otherwise. As I have laid out on the slide here, phone numbers are a good example. Social media accounts are a good example. These are things where you have some identity and it's represented potentially digitally, but it's by this centralized entity. And so to kind of get around that and having all of these different identities, there's sort of this idea that is cropped up of having your sort of identity provider, right? You can log in with a variety of different services, whether it's Facebook or Google or others, and I think that everyone's probably pretty familiar with this. But the thing that I think we should really be striving for is making sure that we have equity and ownership in the systems that we're using in our day-to-day lives. And I think that having ownership over our own identity and over our own data is something that should be prioritized more highly than a lot of other things in this conversation. So I think this is really important. But the idea is that you actually are able to issue a decentralized identifier to any of your peers, and any of your peers can issue you a decentralized identifier. And so there's this DID pair that's created every time that two users are interacting in this type of system. And so what's really cool is that if, for example, you have an identity that was issued or an identifier that was issued by somebody to you saying that maybe you have a license to be working on homes, right? You have a license to be doing roofs, and so I hire you to do my roof. You can show me that credential, but I have to trust that the issuer actually should be issuing those types of credentials. And so this is something that they've thought about quite a bit. And if you add sort of this concept of having an authority that is saying whether or not those credentials are actually supposed to be issued, right? So like say you've got this house roofing authority that decides whether or not people are authorized to be doing roofs. It definitely is helpful because then the issuer can go to the authority and say, hey, I want to get my license for doing roofs, and here's why I should have that, and the governance authority is able to say, you know, that makes sense or that doesn't make sense, and issue that authority. But in the context of the sort of individual who's getting their home roofed, they would need to have a separate transaction going to that governance authority, and things get pretty messy. There's not really a way to directly, when interacting with that person who's going to do my roof, how do I actually verify that they are supposed to be doing that? And so we still have to trust the issuer in this model. And so the sort of concept that has been used to solve this issue is having a registry where at the point in time where the issuer is going to go to this governance authority and say, hey, I need to be able to do roofs, and I need you to sort of validate that I can do that and put that somewhere. The governance authority stores that along with their sort of signature. That credential is stored in a registry. And so then at any point, anybody can come and use that registry in order to sort of check credentials that were issued. And therefore, when the holder goes to the verifier, in the context of the example I gave, that's when this roofing person comes and says they want to do my roof, I can look at that registry and I can tell that they are supposed to be able to do my roof because I no longer have to trust the issuer. I'm able to look at that trust registry, which is managed by a governance authority, which we've all accepted is allowed to be doing that. Maybe this governance authority is, like I said, the house roofing authority, but maybe it's the University of Illinois saying whether or not somebody is supposed to be able to issue a certain license or credential or something. So there's a lot of work still left to be done in self-sovereign identity, but I think that it's a worthwhile industry, and I think that there's a reason that the estimates right now are that it's going to be over $100 billion industry in only 2 years. I think that this is the way that people are going to interact in the near future, and really excited about it. So to give, again, just a quick summary, decentralized finance is primarily made up of these peer-to-peer systems which allow for people to collaborate or exchange in different markets, and these are enabled by smart contracts. The types of systems that are built out in decentralized finance have a lot of opportunities to earn a lot of money. A lot of people have seen that, but it's something that also can lose a lot of money, so obviously be careful. And by participating in decentralized finance, users are actually securing the systems that they're using, and so sort of having this self-ownership of these systems is sort of the big ethos. It's also still, as I said, a very new industry, and these sort of concepts of self-sovereign digital identities are just now cropping up, and the applications, I think, are going to be quite endless, having credit scores and the ability to do sort of risk assessments on a variety of users, all on-chain, is going to be sort of game-changing for decentralized finance. But that's the end of my talk. I hope that people are feeling like they got something out of it, and if anybody has any questions, I'd be happy to answer those now.
Okay, no, it's good. So how does the organization manage the trust registry, out of curiosity? What does that system look like?
Yeah, it's quite agnostic, I think, at this point in time. So it could be simple as GitHub, but I think it would probably be something that's actually stored in a blockchain in and of itself. The big thing is it needs to be transparent and it needs to be accessible by everybody. And then, like I said, I mean, you can use a variety of methods within cryptography to make sure that only the right authority is able to sign on behalf of that registry. Yeah. Of course.
Thank you for introducing this new market. Can you describe the current market activities in terms of volumes and transactions? Some more details?
Yeah. I know that within DAOs, at least as of a couple weeks ago, the sort of total assets under management was like 8.2 billion, I want to say. I know that there's the current market for decentralized finance is in the hundreds of billions, but it's not as high as it was sort of near the end of last year, and the market has come down quite a bit. So I don't know exact statistics on volumes, but it is still in the tens of billions throughout these markets.
Okay, so here's a question from the online audience. Like, the automatic market maker, the AMM, are extremely capital inefficient. So have there been any recent development that help alleviate some of this inefficiency? Thank you.
Yeah. So what's kind of funny is the order book model actually has no slippage, so it's like fully capitally efficient, and by kind of extending what an order book means and adding a variety of sort of what is being called in the Cardano ecosystem programmable swaps, there can be capitally efficient markets that allow for even more sort of diverse user experience than in the current decentralized exchanges. But to my knowledge, there are no products out there that sort of take advantage of all of the research as of yet. I do know of like a handful of order books though, and like I said, the order books that are decentralized exchange order books are fully capitally efficient. But yeah, no, in the context of the sort of AMM model, which is more widely used, I'm not aware of anything to sort of increase the capital efficiency all that much past just sort of the Uniswap v3 model.
Okay, and here's another question from the online audience. Like, how do you think about the higher and higher gas fee problem in DeFi? Because the gas fee might being like even eat like most of the profit of some of protocols. Yeah.
When I started getting into blockchain development, I decided explicitly not to work within the Ethereum virtual machine ecosystems because of this issue. Cardano doesn't have a fee market, so non-dependent upon congestion, the fees are always the same. And that is the same with some other blockchains as well. Yeah, as of right now, definitely Cardano is where I'm building, and I'm working on a platform for anybody to easily create a DAO with just a couple of clicks in our interface, and also extend that DAO using a variety of different sort of modules or extensions that we're building. But I'm definitely biased towards Cardano, and I think it's the best ecosystem to be building in. I'll fully admit, though, that there's a much higher sort of barrier to entry when developing in Cardano than in other ecosystems. I think a lot of that, like I said earlier on, is due to a lack of design patterns that have been established within the extended UTXO model. But I think, yeah, Cardano all the way.
There are no other questions from the online audience, but I have a question. I'm sorry if I can. So, because I want to know, like, how do you think of some like economic rationale for some DeFi protocols? Because I've been looking through many of the documents of the DeFi protocols, and I've rarely seen some DeFi protocols that document have a proof of the validity of their economic rationale. For example, I'm not sure if you know the synthetics, the DeFi derivative, and they have a design of a shared debt. Like if I got a loss, then as a member, you have to share part of the loss with me. But as a consequence, it means that we're bet on the worst investor will benefit the most in a pool. Like, how do you think of like the rationale?
Yeah, I think it depends on the system that you're looking at. I think that generally a lot of these systems are built to mitigate risk. When it comes to synthetics and sort of having losses that are shared losses, I think that is a valid point. I think the best example of a synthetic that has sort of followed the route that they ought to is the DAI stablecoin, which is in and of itself a synthetic, and I don't think I can think of any situations where there's been issues like that with the DAI stablecoin and MakerDAO, but I think having proofs of validity for these systems is something that is being pushed more and more as there are more and more decentralized finance hacks. Like I said earlier today, there's been a couple $100 million lost in just the past couple of days. So I think obviously there's shared losses there, and that's not because of an invalid model, but I think that having having mathematical models that are well proven with certain axioms, I think is essential to the future of decentralized finance actually being leveraged by everybody.
So Riley, I have a question. So most of the blockchain applications we've seen so far are in the finance domain, right? DeFi. So are there other non-DeFi applications you see that will be promising, will take off in the near future?
Yeah, I think being able to use blockchain for a variety of collaborative efforts is something that I'm excited about. There's people that come to me every day asking for advice or help on creating decentralized autonomous organizations, and I think that that's one of the things I get really excited about in blockchain that's not always financially related, but I think also with topics such as self-sovereign identity, reputation systems are going to be hugely based on blockchain, and I think healthcare data being able to be owned by individuals as opposed to centralized entities, and kind of having the right to store your information where you want it to be stored, and then having proofs of that information on blockchain to where it's easily auditable and you can sort of share what you want and not share what you don't. Those types of things excite me and are not financially related. There's definitely a lot of use cases, I'm sure, that haven't been uncovered, but I think the financial ones are probably the easiest to get people to build just because of the amount of incentive behind it.
Hi, Rennie. So I have a question regarding, so like when you look at the history of decentralized finance, like do you see there's this kind of people that are like intentionally avoiding some shortcomings of the like traditional finance system or the economic system that we already seen?
So yeah, I mean, I think when it comes to trying to avoid the sort of shortcomings of the traditional system, the primary benefit of using decentralized finance always comes back down to the sort of non-censorability, and then also the sort of self-ownership, self-sovereignty of these systems. I think that those are the primary benefits. I can't really, yeah. And I'm also no historian, to be fair. I know a lot of people that are better versed in maybe that topic than I am, but no, that's. I think the self-sovereignty of it and getting away from censorable systems is the primary benefit.